Okay, welcome to the video. This is part one of systems, and it's the first part of part one of systems. We're going to be talking about water systems. Okay, so water is very important in any building, right? And the first thing we're going to talk about is the delivery. How do we get our water? You're going to get it from one of two places. You're going to get it from city water or well water. If you're in a property, well, most commercial properties are going to usually be on city water. If it is available, you're going to be on it. Most places require, most municipalities require the use of city water if it's available. I actually owned a house that had a old well on it that had been hooked up to the house in the 30s and 40s, and the city, long before I owned it, the city dictated that we couldn't be used. So I had this beautiful well that I couldn't use. For whatever the reason. But so you have well water, city water. City water generally comes from reservoirs or pumped in from different places or whatever, depending on where you live. Okay, so how do we get the water from the city or the well into our house, into the faucets, to the toilets, to the showers? How do we do that? There's two types of systems. There's going to be a constant pressure system, or a gravity-fed system. All right. Now, in small single-family dwellings, or even multiple family dwellings, but a relatively small, 1 to 2 to 3 stories ish, the constant pressure system is what you're going to use. A pump takes it from the supply, brings it to where it needs to be. You turn the faucet, a pump turns on, brings the water there. Okay. Now, as you can imagine, if you have a very tall building with multiple stories and 100 faucets, the further away from the pump, the worse it's going to be, right? So there's a different system for those types of applications, and that is gravity fed. Gravity fed, the pump is there, but it only is used for one purpose. It pumps water from the source, whether city or well, to a large holding tank in the attic or on the roof, and then it relies on gravity to feed the faucets, the toilets, and the showers. You turn the faucet on, it's just releasing a valve. There's that pressure. Now, water is heavy, okay? It's 8.35 pounds per gallon. So the higher up it is, the more it's got to go. It starts at a big pipe, small pipe, small pipe, small pipe. It builds up a pretty good pressure. So don't think that gravity-fed systems don't apply pressure or supply good water pressure. Actually, depending on where you are in the food chain or the water position or whatever, it could be really, really good water pressure. Okay, so those are the two feed systems. Let's talk about removing water. It's got to go somewhere, right? We got to get the water out of our building, right? So it goes into sewer, right? Now there's two types of sewers. There's sanitary sewers and storm sewers, all right? They're very different. They're two different systems, all right? The sanitary system is what comes out of the house, right? From a faucet, from the shower, from the toilet, all of that, right? Now, that water is treated. When it goes out somewhere along its journey to wherever, it gets treated, okay? Now, in that, generally speaking, there is no pumps because it relies solely on gravity to put it into the sewer system, unless the sewer system, if you have like an underground basement or a toilet in the basement or something like that, you will need an injector pump, what's called an injector pump, to get it up to the sewer because water does not flow up, okay? So gravity is generally what powers water exiting the building, but unless the water exits the building below the sewer system, then you need an injector pump. Okay, so that system is the sanitary septic system, or sanitary sewer system, and then we have the storm sewer system. The storm sewer system is the water from outside, rainwater, water from garden hoses, stuff like that. That goes directly into a different sewer system, but that is not treated. All right, so that is the big difference between the two. One is treated, one is not. Okay. So, and then the last thing I want to talk about with your sanitary water or sanitary waste, sanitary systems, is let's say you don't live on a sewer system. So what do you have? You have a septic tank. What is a septic tank? Septic tanks are pretty interesting. What they are is a big tank underground in your property. Okay. Now, hopefully for large properties, I'm sure there is large septic tanks, but hopefully if you actually run a large facility, hospitality facility, you have sewer, city sewer, right? But what a septic system is a large tank in the ground. All of the waste, the solid waste, everything, from the toilets or whatever, goes in there and it settles. The settling on the bottom is what's called the sludge, and then there's a scum on the top, all right? So you have settle and scum. Things that are heavy go to the bottom, things that are light go to the top. Everything in between that, in theory, should be relatively clean, okay? Now, with that, there's also septic systems will have, I don't know if they're chemicals or something natural, but there's enzymes in there that help tear down that waste, okay? So when a septic system is working good, it's fine. But so what happens with that water, that clean water in between the scum and the sludge? It is actually left to, well, I don't want to say leak out, but leach out of the tank into the surrounding ground because it's supposedly relatively clean water. So if you have a septic system and the water, the water around where the septic tank is buried smells, well, then there's something wrong, because generally speaking, that water that is leached out should be relatively clean. All right, relatively. It's not clean enough to drink. At least I'm not going to do it anyway. Okay, so next thing. Okay, so a couple more things when it comes to evacuating water from the house or sewer, water going into the sewer. Okay, we have, for toilets and sinks, we have S-traps and P-traps, primarily S-traps and P-traps are primarily for sinks, but there's S-traps for toilets as well. There's an excellent diagram of a S-trap on page 85 of your textbook. The digital copy, I don't know where it is. You just have to find it. It's under P-traps and S-traps. All right, so basically all it does is, because instead of the water going straight down, if the water goes straight down and that left a clean pipe or clear pipe, that means all the sewer gases, all the smelly stuff that comes from the sewer would come right back up into the house. So we have an S-trap, right? It looks like this. And down at the bottom of that, where it's called the siphon, okay, in the bottom there, the water will stay there. So clear pipe, water. So there's water staying there, separating the gases from the sewer from your house. Okay, so it's very important. Traps are very important. Without a trap, it's going to stink. All right, and code says you have to have one anyway. So there we go. And then we have grease traps in kitchens. All of you who've ever worked in a kitchen know what a grease trap is. Basically, it's a two water separated into two sections, and the grease will separate and stay on one side, and the clear water will be pushed to the other side. Okay, so that's a grease trap. All right, so let's move on to the next topic. All right, for water, let's talk about quality. We want to make sure that our water is high quality. Certainly, if it's potable, it means that it's safe to drink, right? So we want to look at the color. All right. Anybody who grew up in the 60s or 70s, whatever, in old houses has seen water that if you put it in a glass, it looks like rust. And that's because back in the day, they used cast iron pipes. You don't see that very often anymore. And generally speaking, the facilities that we're going to be managing won't have that. They'll have PVC pipes. But anyway, color is a big indication of quality, right? Another one is odor. If your water smells, a lot of water will smell chlorine, and we're going to talk about that later. That's not good, by the way. And if it smells, it could smell metallic, other things, right? Clarity, if it's clear, not just the color, but it might be white or no color at all, but still kind of translucent. That's not good. Mineral content, that is something that would have to be checked, but if there's a lot of zinc, a lot of iron or other things in there, I mean, there's a certain amount of those trace elements are important, but you don't want too many of them. And then acidity or alkali of the water, if it's got too much, if it's too high on the acidic pH or too low, that's a problem. Okay, so that's just some of the things to consider when you're talking about water quality. Now let's talk about heating water. When I talk about heating water, I'm talking about heating, getting it hot, okay? Now, there is such a thing as heating water, heating the house with water, forced hot water, or steam or something like that. And those will be talked about in later chapters. But for this, we're briefly going to talk about hot water in two forms, okay? One of them is domestic hot water, and the other one is heating hot water. They should never be together. All right, heating hot water is water that's used for one of those systems that we're going to talk about, forced hot water, where hot water goes through baseboards or radiators or something like that. Okay, that is not water that cycles through that old-timey radiator and then goes right back into your drinking water. It's different. It's completely different. Okay, so domestic hot water is all the water that goes in your sinks, the toilets, the showers, all that stuff. All right, so that's domestic hot water. Heating hot water, so DWH, or DHW, excuse me, is domestic hot water. HHW is heating hot water. Two different things altogether, okay? Now, how hot should domestic hot water be? Well, when it gets to the tap, it may be not that hot, but it should be relatively hot. For the same reason we keep food out of the danger zone, you want to keep our water out of the danger zone. So when we have a tank, a hot water tank, we want to keep it around 140. Okay, and that is so it delivers warm water to where you need it, number one, but number two, it's actually more sanitary. The bacteria doesn't build up in anything over that. Okay, so we also have other systems like instant hot water, instantaneous heaters, sometimes called tankless water heaters. Those I don't know if that's something that's generally recommended for big buildings. The consumption of fuel and stuff to heat that water, there's a lot of argument back and forth in that. But generally speaking, for bigger properties, you probably won't use that, or maybe you do. I don't know. But that's a different type. So if you don't have that, you have a traditional water. We've all seen the big tanks, whatever. Now, in a large facility, it's going to be more than just a bunch of hot water heaters. It's going to be a boiler, a big old thing, okay? So now we're going to move into some other stuff. All right, so let's talk now about other uses of water at the hospitality facility. Can you think of anything else other than toilets, sinks, water, showers? Even the dishwashers and whatever. Other than that, what are some other things that we use water for? Well, pools, spas, stuff like that, right? So that's got its own concerns, right? Because that is outside of the building, outside of the system, domestic hot water and all that other stuff, or domestic water. But it's still water that we use, all right? So how do we keep swimming pools clean, all right? What's the chemistry behind pools? Well, there's different ways to do it. You can do a chemical breakdown system, you can have an ozone system, or you can have a saline system, okay? Let's talk about the first one, which is the chemical breakdown system. This is your typical pool that uses chemicals like chlorine and things like that. All of those shocking things. I'm not a pool guy, never have been, never owned a pool, but I know that there's a lot that goes into it, right? You have to check it and all that other stuff. One thing that I found out in this book, in this class, that I never knew is, and this is in your homework, is when you smell chlorine, really heavy chlorine in a pool, some people think, well, it's clean because there's a lot of chlorine, so they smell. A clean pool with proper chemicals should not smell that bad. All right, should be just faint smell of chlorine. When the chlorine has a really intense smell, that means it's working overtime. Okay, so when you really smell a lot of chlorine in a pool, don't go in it. Don't swim in it, because a lot of people have peed in it, basically. All right, it's dirty. All right, it's at the point where it needs to be cleaned. All right, so that's an interesting thing that I never knew. Ozone pool systems are a little bit different. They use less chemicals. It's actually it's like a machine, and it's very, very involved. It uses less chemicals. I'm not really too sure about how the mechanics of it works, but just understand that this is a different system. It is a little bit more expensive. It does provide a cleaner pool, all right, and without chemicals. And we all, in this day and age, we're always trying to reduce chemicals and harmful things, right? But it's not always allowed in every jurisdiction. So you want to check, make sure if you're going to do that. And then the other one is saline pools. So that's saltwater pool. Here in Wilmington, a lot of the apartment buildings now have saltwater pools, right? One of the reasons why they have saltwater pools is it's less chemicals. It's done with salt. The salt is what does the cleaning instead of other harsh chemicals. There are some chemicals, but not as many. And but one of the biggest things around here is if you want a 4-season pool, it's a saline pool, all right? They don't freeze, all right? Whether or not you'd want to go swimming in a pool that is cold enough to freeze if it didn't have salt in it, that's on you. But that is one of the reasons why I've always been told, oh, it's a saltwater pool. You can go in December. And I'm like, yeah, no. Anyway, so let's talk about pools. There's a lot going on with pools, and you know, those of you who've taken HRM 140, the legal, we have an entire chapter on pool safety and well, not pool safety, but how you can be sued from pools. But generally speaking, you're not required in most places to have lifeguards. But if you do have a lifeguard, make sure they're trained, okay? Signage, you are required in many municipalities to have signage saying swim at your own risk, and then different signs that tell people the different information they need to know. Safety equipment must be present, all right? In a hotel, if you have a pool without safety equipment, you are waiting to be sued. Right? And you will lose hard, okay? And you're required to have fencing. Now, in the off-season, winter shutdown, most places nowadays require some kind of net or something, not a net, but like a covering or whatever for protection. Now, that goes along with the fencing. Pools now must have a fence. You can't have a pool, you know, certainly in a hotel, without a fence. The idea of the fence is to keep kids from wandering in there, okay? Kids who are with their parents at the hotel, yes, okay, they can go in. But outside folks just wandering around, kids be, oh, a pool, and then fall in, it's a problem. All right, so you must have all that. Now let's talk about spas. Spas can be a safety concern, right? There's something called I can't say the word, vasodilation, okay? And basically what that is when you're in hot water, it expands your blood vessels or your veins, arteries, and that lowers your blood pressure. Because you think about it, if my blood's going through here, I have a certain blood pressure. If all of a sudden the blood's going through this, that pressure just dries up, right? So it can be dangerous, all right? Especially for little kids. Little kids should never go into a hot tub, okay? They're at that point where that word, vessel, whatever, is bad for them. And probably older folks too, I would imagine. Generally speaking, anything that's bad for kids is bad for old people. But anyway, be aware of that, right? So those are some dangers. So if you have hot tubs or whatever, just keep an eye on folks and make sure that they're healthy. And another thing is I've experienced this myself. Hot tubs can dehydrate you. You sweat into water, you don't notice you're sweating because it's going right into hot water. So it definitely can dehydrate you. So the whole thing about drinking in the hot tub, a lot of people do it. It's really bad. Okay. Anyway, moving forward. The other thing about waters like that is if you start to see, okay, there's bubbles, right? Bubble, 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 bubble. I don't know why I said it that way, but there's bubbles going on, a lot of agitation in the water. It's fun, right? It's a good thing. But when you start seeing that bubbles turning to like a scum or to like a foam that stays there, then you have a very dirty hot tub and you need to drain it, clean it, and refill it. Okay? So let's think. There's a lot of ways. The book has a bunch of ways of how to conserve water. We talked about that in previous chapters, so I'm going to leave you to that about different ways to reduce water consumption. Just be smart. Turn faucets off when they're not needed. You do full loads of laundry. Do full loads of dishwashing. Don't wash by hand with don't dishwash by hand without water in the sink, but just doing it with the water going down the drain. It's not good. All right, use a 3-compartment sink or whatever. Okay, so that's it for chapter, what is this? Chapter 6, and then we're going to go to 7 and 8. So it's a lot going on this week.